You may already know the episode of the TV series The Big Bang Theory where Sheldon states that he uses his own version of rock, paper, scissors, but with more options. He called this version Rock, Paper, Scissors, Lizard, Spock. Since I have seen that episode the first time, I wanted to know if this game makes sense and is fair. I think this is enough to take a look at Rock, Paper, Scissors, Lizard, Spock from a mathematical point of view. But first of all, let's take a look at the normal version of Rock, Paper, Scissors. I'm sure you already know the rules. So two people play against each other. They can form one of the three figures, rock, paper or scissors, with their hands. Both players show their chosen figure to the other player at the same time. Now, rock beats scissors, paper beats rock, and scissors beats paper. You can also visualize this game by using a graph, which you can see here. So this graph tells you that paper beats rock, rock beats scissors, and scissors beats paper. There you can also see that this game seems fair. Every figure is weak against a figure and strong against another one. This indicates fairness. Another way of visualizing this game is by using a so-called payoff matrix. So here on the left of the matrix, you write the strategies or figures you can use. Here on the top of the matrix, you write the strategies or figures your opponent can use. Inside of the matrix, you write the points you get when you play strategy A versus a strategy B your opponent has chosen. In this case, +1 means you win, -1 means you lose, and 0 means a draw. So when you, for example, play rock against paper, you lose 1 point, so -1. When you play rock against scissors, you win, so you get 1 point, so +1. The same here. For example, when you use scissors against paper, you win 1 point. When you use scissors against rock, you lose 1 point. Scissor against scissors grants you 0 points, which is a draw, so 0. With the help of this matrix here, you can calculate the so-called Nash equilibrium. The Nash equilibrium is a probability vector and defined as the best strategy against itself when it comes to the expected payoff. And in this case here, the Nash strategy is P is equal to 1/3, 1/3, 1/3. So the Nash strategy tells us to play rock, paper and scissors all with the same probability, which is 1/3. So rock with a probability of 1/3, paper with a probability of 1/3, and scissors with a probability of 1/3. So this Nash strategy, which tells us to play everything at the same probability, also indicates the fairness of this game. But don't believe such games are always fair. Back in school, we used to play the game rock, paper, scissors, well, which adds one new figure to the basic version of the game, the well. The well beats rock and scissors, but paper beats the well. When visualizing this game in a graph, you immediately see that something's not right. Some figures are better than others. For example, the well beats scissors and rock, but the rock only beats scissors. So this tells us, or this indicates, unfairness. When taking a look at the payoff matrix, which looks like this here, you can see that playing the well is always a better idea than playing rock. Because well always leads to better results than rock, which you can see here. So 1 is larger or equal 0, -1 is larger or equal -1, 1 is larger or equal 1, and 0 is larger or equal -1, which means that playing well is always a better idea than playing rock, or in other words, the strategy well dominates the strategy rock. The Nash equilibrium shows us similar results. Its P is equal to 0, 1/3, 1/3, and 1/3, which tells us don't play rock, but play every other figure with the same probability. So play rock with probability 0. So this game's not fair. You could make it fair by eliminating rock and replacing it with well. Now let's take a look at rock, paper, scissors, lizard, Spock. So here we have two new figures, Lizard and Spock. The rules are as follows. Lizard beats paper and Spock, but rock and scissors beat Lizard. Spock beats rock and scissors, but paper and lizard beat Spock. So the rules are explained as follows. The lizard eats the paper, and the lizard poisons Spock. The rock and the scissors both kill the lizard. Spock vaporizes the stone and breaks down the scissors. The paper disproves Spock, and the lizard poisons Spock, as I said before. The interactions between rock, paper, and scissors are the same as in the basic version of the game. You can also visualize this game in a picture, which you can see here. So when you take a look at this picture, the game seems fair, because every figure is strong against two figures and weak against two figures. This indicates fairness. For example, when you take a look at Lizard, Lizard is strong against Spock and strong against paper, but it's weak against scissors and rock. When you take a look at Scissors, Scissors is strong against paper and strong against Lizard, but it's weak against rock and Spock. So every figure is strong against two figures and weak against two other figures. This indicates fairness. Okay, you can also write down the payoff matrix of this game here, and this matrix looks like this here. I calculated the Nash strategy for this version of the game. I found out that the probability vector P is equal to 1/5, 1/5, 1/5, 1/5, 1/5 is a Nash strategy, which tells us to play every strategy rock, paper, scissors, lizard, and Spock with the same probability. So this here is the Nash strategy. This is very similar to the basic version of the game and indicates fairness. So because we have no figures that are better than others, we can say that the game is fair. But is the LizardSpock version better than the normal version of the game? Well, in the LizardSpock version of the game, you have to memorize more rules. But on the other hand, it is less likely that two people will play the same figures at the same time, which means a draw. On the other hand, the basic version or the normal version of the game has very easy rules, but on the other hand, it is more likely to get a draw, so that two people will play the same figures at the same time. So in the end, you have to decide by yourself if you want to play the original version of this game or a more modern version of the game. Okay, I hope you liked this video. If so, please consider subscribing to my channel so I can keep producing videos.